Alright, we're going to look at section 2.1, Introduction to Functions. The first thing we want to do is look at some vocabulary. So this vocabulary should look familiar to you. The first word is relation. A relation in math is any set of ordered pairs, x comma y, that we have, because we can talk about a bunch of different points basically. Whatever is causing that x and y to go with each other, that's the relation between them. Then we have domain, which should be very familiar to us. The domain of a relation is its x values, and range, the range of a relation is its y values. Functions are a special type of relation where everything in the domain goes to exactly one item in the range. So the fact that this word right here is 1, that's what's important for functions. So if you look at the two examples we have here, we have, this example to start off with. Each of these things in the domain goes to exactly one thing in the range, signified by the arrows here. So we would say that this is a function because each thing in the domain goes to exactly one thing in the range. This second example here, if we look at it, we have one thing from 3 to 8, then we look at 4 and 4 goes to 5 and 4 goes to 9. So something in the domain is going to more than one thing in the range, so that makes it not a function. So we don't generally look at figures like these to determine whether something is a function or not. So the first way that we're going to look at it is using a set of ordered pairs. So example 1. The easiest way to tell if a set of ordered pairs is a function is to look at the x values. X values are what come first in your ordered pair. Okay, what we're going to say, our definition basically for a function in this case is that if all of our x values are different, then the relation is a function. Okay, so if you look, 2, 4, 6, 9, all of those are different, so we would say that this is a function. Then it wants us to give the domain and range for each relation. So our domain for this set of ordered pairs is all of our x values. So we just need to list them. 2, 4, 6, and 9. Then for the range, it's all of our y values. So the things I don't have underlined right now. So 3, 5, 5, and 10. We only need to list that 5 once. We don't have to list it multiple times. So that's part A. Well, let's look at another example then. On B, if we look at our x values, we want to know, are all of our x values different? Well, no. We have two x values that are the same. We have 1, 2 and 1, 10 that have the same x values. We want to check and see, are these the same points, 1, 2 and 1, 10? They're not the same point. They have different y values, so this is not a function. Okay, not a function. Because all of our x values are not different. We have an x value that repeats. Our domain is 1, 3, 6, and 1, so that's just 1, 3, and 6. Our range is 2, 3, 8, and 10. And then our last one here, if we look at our x values, we've got 1 and 4, 2, and 1. So our x values, we have something repeating. But if you look at these 2 points, 1, 5, and 1, 5, those are the same exact point. So it's basically like, okay, well, they repeated the same exact point again. We can throw that out and not mess with that. It's just like extra information. Now if we look, all of our x values are different. So yes, this is a function. That's an I, not an L. My pen didn't come up very well, sorry. So our domain would be 1, 4, 2, or you could put them in order and make it 1, 2, 4. And our range is just 5, because all of them are 5. Notice that it doesn't matter if our y's repeat, just that our x's repeated, or didn't repeat. So example 2, what we want to do is find the indicated function value. This is a special notation that we haven't used yet this year. This is not f times x, which is normally what a parentheses situation like this might mean. This is saying f of x. And what it lets us do is it lets us find things like f of 4, where what we're saying is take whatever is in the parentheses and plug it in for every single x that we have. So we do f of 4 equals negative 5 times 4 squared minus 4 times 4 plus 3. And we just work out what that is. So you can use your calculator, or you can use order of operations and do it by hand, whichever is easier for you. I end up with negative 93. So g of negative 2, we would do the same thing. Plug in that negative 2. And when you do this, whether it's by hand or in the calculator, if you're plugging in a negative number, put it in parentheses. Because, especially if you're doing it on the calculator, your calculator needs to know that we're taking the entire negative 2 to the 4th and not just 2 to the 4th. Because that's going to make a difference. Negative 2 to the 4th power is positive 16. Negative 2 to the 3rd power would give us negative 8. So then that's 32 plus 40, which is 72. The last kind of example we have here, they give us a table of values, and then on A here they ask us what is f of negative 8. Well, what's normally here is, that arrow sucks. Okay, what's normally there is an x, f of x, normally what we say. So they're telling us x equals negative 8, and they want to know what goes with that. Well, our x values are this part of our table, and so that means I would look at negative 8 right here, and I need to write as my answer the value that goes with it. So the answer to f of negative 8 is 9. Because those go together in the table. For part B, similar thing is happening, but now instead of f of negative 8, we have f of positive 8. So we look at our table at 8 on the part that says x. We go across, f of 8 is 13. Then they switch it up here on C. For what value of x is f of x equal to 11? Well, now they're saying f of x is 11. If you look at our table, this column is labeled f of x, and so we need to look at where 11 is on the right side, and it goes with 0. So x equals 0. Two things to add to this is they might give us something like f of x equals x plus 3. And then they might ask us, what is f of 4a? Well, f of 4a, you'd simply plug that 4a in where x is, this x right here. Okay, so that's 4a plus 3. Those aren't like terms, so we can't add anything together. This would be our answer to f of 4a. Or they could give us like f of a plus 5. So we plug the a plus 5 in where x is, and then we have a plus 3. Now I do have like terms. I can do 5 plus 8 and get, 5 plus 3 and get 8. So that would be our answer. And then if you're working some of these out by hand, there's a point where you end up with 3 times 2/3 minus 2. Well, 3 is the same as 3 over 1. The 3's cancel, giving you 2 minus 2, which is 0. So that's an example of how that works.